Yeah, okay, let's continue with our latest last call from Paul. Paul is CDAIO, interim CDAIO of DEEP.AI. He's also coach or data scientist, data analyst. He's lecturer at the Fresenius Medical School and has maybe the most experience in years in this room here, all of us in this sector. So, yeah, raise your attention for Paul. Welcome to the event.
Thank you, Thomas. Yeah, having the most experience probably means I'm just old. And still, I hope you listen to my experiences. I've been around in healthcare and in healthcare AI for quite some time now. And I realized that it's hard getting AI use cases into production, especially in the German healthcare system, as we have discussed today already. And for this talk, I thought back on all my experiences and I built 7 different hypotheses, which I want to share with you today, why that is. It's like a personal journey throughout my career. When I started in healthcare, I looked like that, and you will realize I looked much younger then, and telephone still had wires on it, so quite a long time ago. And my first hypothesis, when I started, 2011, that was 2011, building AI solutions in healthcare with healthcare data, I first thought, okay, we need to collect data. The reason that machine learning, as we called it back then, or data science, has not been established in healthcare is that there's no central data repository. So we went about collecting data. And by the way, I only use screenshots from old presentations from me for today. So nothing new. That one is from 2011. We went to sickness funds, insurance companies in Germany, to the Betriebskrankenkassen, 80 of them, and we collected all their data, 7 million patients over 6 years, resulting in 3 billion data points. And that slide, I mean, it's in German. Most of my slides are in German because usually it's very German-centric, the healthcare system, shows the diagnosis for ambulatory care. So for actual doctors, we had 1.2 billion of those data points in the database, so quite a lot. But still, we learned we were missing information-rich data. Data from the point of care, from hospital systems, where there's more information than the sickness funds get. So not quite solved back then. Now let's fast forward to 2022. I've joined the BG Kliniken in 2021 as Chief Data Officer. BG Kliniken are the 4th largest hospital group in Germany. So we have, or they have, and I'm now consulting independently, but no, back then BG Kliniken have 9 hospitals all over Germany. And I was very excited because as Chief Data Officer for such a large hospital group, I thought now I can really establish AI in healthcare. Because I thought as a hospital group, we would have access to all that information-rich data. Turns out we haven't had. We don't. Thing is, healthcare data is even inside a hospital structured in silos. So each system has its own data structure. And the first thing I did was I started a project to build another data layer on top of all our legacy systems called Interoperability platform. You see that here in red. But that project is a 5-year project. And only if we have that, we can establish AI use cases on all our data for the BG Kliniken. So no small, fast prototyping. So still a yes. We are still lacking data in healthcare. So my next hypothesis, let's go back to 2011. We then had those sickness fund data, 3 billion data points, started our first trials with machine learning algorithms. Turned out healthcare data is really complex. The reason is we have a lot of different categorical variables like alone diagnoses from the ICD-10 codes, there are 13,000. And if you go into drugs, medication, it becomes a nightmare because any metrics you build with that data becomes really huge and sparse. And that's a problem for all algorithms in machine learning. Fast forward to today. Today is everything about SNOMED. I don't know, who of you has heard about SNOMED? At least some people working in the medical space probably have. SNOMED is really great. It contains 350,000 active clinical concepts, like a knowledge graph. People really like working with it. I don't know why, because it's really cluttered and I don't really understand it. And I mean, we have now 350,000 different categories there. And even if you would have 3 billion data points, and each of those data points is organized into, or has attached one of those categories, it's still sparse. So we would need even more data to really find patterns. So still, yes, it's difficult to work with that kind of data. Anyway, let's jump back. 2011, we had the data, 3 billion data points. We also find some solutions for working with sparse matrices. The next thing we encountered was that the tech backend was not ready. We used a traditional SQL data warehouse back then. And all queries we had, even simple ones, took ages. Our analytical system was SAS. I don't know if you have worked with SAS. It's like a statistical software. It's like R. Thing is, it really didn't work. Took ages. So we needed another approach, and we found it with Spark, like a high-performance data cluster. What you see here are the numbers for retrieval, data retrieval for a medium complex query. Like with SAS, it took more than 1 hour, and with that new Spark cluster, it took just a couple of seconds. So solved. We solved it in 2014. We were able to really work with the data, and it has been solved since then. Now, in between, a couple of years ago, we had that problem again. We as a community in healthcare AI, working with healthcare data, or even working with data, because those large models, foundation models, they need GPUs. And then we had all of a sudden, again, the question, how do we use clusters of GPUs? Again, has been solved. So you can go to any hyperscaler you like AWS, Microsoft Azure. You can rent your GPU clusters there. You can train your models or use it for inference, whatever you like. So solved, but not really in healthcare. Thing is, there's a lot of cultural aversion against using hyperscalers. So if you work in a hospital setting, or doesn't matter, work in any healthcare, with any healthcare provider in Germany, they tend not to use any cloud. So, and how do you go about even using an LLM that needs more than one GPU? You would need to put those GPUs in your own data center, and all of a sudden it becomes really like a high initial investment. You cannot really fast prove that that thing works and that the prototype makes sense to have evolved or to evolve it in a production setting. So that's really still a bit of an issue in healthcare, although technology is solved. So the next thing we encountered, I mean, we had all those data, we had machine learning algorithms working with it, and then it turned out it's complex to distinguish between patterns in the data that are just noise, or patterns that are common knowledge, and patterns in the middle that are interesting. And I'm not a physician. I can't do that. I can't say whether that's interesting what we found there. So we needed non-experts. And with that, I mean non-technical experts to use machine learning, to use AI on the data. What we did is we created that front end, 2014. I mean, I know it looks ugly. But it's 10 years ago. Yeah. So, and it enabled employees of sickness funds to use advanced machine learning on their data. And they did that. And so solved it somehow. And fast forward today has been solved even better. I mean, nowadays we just use that small window of text input, put in some question, and then the magic happens and we get an answer. So, and Google has trained us to use that kind of text windows for years now. So as an interface, that's perfect as it gets. So now non-experts can use AI very easily, solved. Yeah, and we solved it back then as well, and still it didn't scale. Our solution didn't scale. We had 3 sickness funds working with it, and in each sickness fund there were 2 to 3 users, so 8, 9 power users working with our solution, which was good for kind of startup that we were. But it didn't scale. We didn't get any other sickness funds working with it, and the reason was that we were lacking workflow integration. No user wants to leave their ecosystem they are used to, copy data or put the data into another system, get the answer and copy it back. That's not how we want to work or how users want to work. And we realized that working with sickness funds, that's not possible. You cannot get into their system ecosystem. It's too closed. Everything is secure. They were even using Internet Explorer 9 back then, which was outdated even 10 years ago. And so no chance to add another software product there. What we did, created another AI product targeted at physicians, at doctors, at the point of care. Behind that, and we created a new front end, obviously. The idea was at the point of care, when the patient comes to the physician, during the visit, there's a new diagnosis, new lab results, new medication prescribed. In the back end, our risk models run and then tell the doctor immediately, attention, that patient has a high risk of getting, in that case, liver disease. Please talk to the patient about it. And here are some suggestions what the patient could do. And we did that for 2,000 different diseases. So we were able to predict 2,000 diseases based on the electronic health record of patients. And we targeted doctors, in the ambulatory care, so real doctors in the healthcare system. We managed to get 80 with 80 doctors, which was quite a lot because we had to talk to each and one of them, which was a lot of sales, and convince them. But still, we were not able to get data from their systems. Turned out even those small little practice management systems they are using, they do not let go of their data. You cannot, they don't have an API to get the data out. And doctors don't want to copy, as I said, they don't want to go to another system, input all the patient data, and then get the risks there. So failed to solve it. No way of getting into that, or those practice management systems. Now, fast forward, again, BG Kliniken, I was chief data officer there. We're very excited to start there. Turned out, even within our hospitals, if you look at the digital journey of a patient, we have not yet achieved full integration. And in one of our hospitals, I won't tell which one, but in one of them, nurses had to input patient data, and I mean name, age, size, in 7 different systems. So they were running around and just typing in data in different systems. They don't want to have another system where they need to input data again. So still the same problem, even with the legacy systems there. Now, fast forward again, and that's the only slide I created new, actually, for today, for you guys. There's a list of AI-enabled medical devices, as the FDA calls it at the FDA website. Medical device is not narrow. It's any AI software that's used in medication, in the medical field, can get listed there, can get registered if you provide the necessary documentation. And they have about 900 AI-enabled medical devices in that list. So, and these are all like algorithms or solutions that are really used in production. Out of these 900, 700, more than 700 are in radiology. So why is that? Why are so many of AI solutions that actually work in production do work in radiology? Yeah, you can take a picture, of course.
The amount of images available to scan and work on.
Yeah, the amount of images available, and they are available because we have a standard there. We have DICOM. DICOM is a standard that has been around for years now. It's working very well, so you can access the data. And it's computer vision. I mean, computer vision has also been around, like from an algorithmic perspective, for more than 10 years now, or even longer, but in real settings for more than 10 years now. And so it's very mature. It's really working. And that leads to a situation where also the radiologists have been working with AI for quite some time now. They are used to have it in their software. So it's part of their usual workflow to just get suggestions from AI. There it works, obviously. And in all other parts of medicine, doesn't really work yet. And then I had another hypothesis over the years. Actually, could be the user, the doctor sitting in front of the computer. Because, I mean, the models we created back then, the risk models I showed you, they were really good. And I thought that would really benefit the patient if you like see or very early on which diseases the patient could get and then try to, do something about it before it actually happens. That would be great, would benefit everyone. And still, doctors didn't use it. I understand that they didn't want to use the other system, copy data and so on, but still, I mean, the benefit would be great. So I thought, could be the user, could be these doctors that don't like to use data. Alva, maybe you are different, but all other doctors are not innovative enough. That was my silent hypothesis. I have never issued that in any kind of sales presentation I did. Now, I brought you a study from 2023, so with the advancement of ChatGPT. Medical Economics, that journal did a survey, 1,000 patients, 500 doctors, and out of those 500 doctors, half said they plan to use AI in the future. So I think that has been kind of solved. AI is there and doctors want to use it. However, if you look a little bit more in detail, and that's a study from 2022, looking at radiologists again, then it still depends from the type of person who is using the AI or even not using it. In that study, they found out that the higher the confidence of a doctor in his or her own abilities is, the higher is the aversion against using AI. Reason is, okay, they think they know it better anyway, and they also think, and that might be true, if they start using AI, they lose their skill. Then on the other hand, if doctors have a low confidence in their own skill set, then they tend to use AI. They really want to do it. Also quite obvious why, but there's a risk in that as well, because I mean, those doctors tend to agree on what the AI recommends. They tend not to challenge it. And then we are in that ethical space, question, discussion, who is responsible in the end? We always say doctor is responsible because he or she has the last saying, but in that case, if you have a low confidence in your own skill set and you trust the AI, you won't overrule it. So again, depends. from the type of person using the AI. And now I have a final hypothesis, and that's one I'm clinging to. I think it's the most important one for today. It's a systemic thing, it's a cultural thing. So there's not that one big wheel we need to turn, and then all of a sudden, healthcare is flooding with AI use cases. It's all a lot of little wheels that need to be turned, and that's hard, and that's why it takes ages, at least in Germany. I brought you two different figures, numbers today that somehow illustrate what I mean with it, and I mean, Alva will recognize them because they're quite similar to what you said. First one is that's again a slide from 2016, where that I created to convince physicians to buy our AI software. That's based on a study, and the important thing is in the middle. In Europe, physicians have only 10 minutes per patient. And 10 minutes might be enough if you have just catch the cold. But it's not enough if you have a lot of diseases and, doctor needs to find out what's actually happening to you. Now, we tend to think that we can solve that with AI. I'm not so sure, because there's a systemic error behind that. If we allow our physicians only 10 minutes with their patients right now, then do we really have the budget to invest in new technology to give them more time? Where's that money? Yeah, where should that money come from? And then we see all those numbers Alva has shown us from consulting agencies, where money in healthcare is going like that, like to the moon. And I wonder, where should that money come from if we now, even today, do not allow our doctors to have more than 10 minutes per patient? And that's just a systemic question, and I'm interested in how that turns out. Another study, and that's more like what Alva said, that it's a Münchner Zeitfresser study. So Munich hospitals were asked, doctors and nurses in Munich hospitals were asked what they spend their time with each day. Turns out 1/4 of the time is just for organizational and administrative tasks. Again, very interesting. And again, the AI people like us, we come and say, okay, we could solve that with AI. My question is a little bit, why didn't we solve it already? There's no real need for doctors to put in all that stuff. We could have digitalized already, and we could have streamlined processes already. We didn't, because it's a high investment, and in healthcare, the money is short. So I'm curious whether AI might allow us to get more money into the system, to solve those issues, just like a Leuchtfackel. I don't know the English term. Something that you can wear before you, and everyone is gathering behind it and is willing to pay for those investments. That might work, and hopefully it does. But it will take time, and it will take a long time. So now I'm at the end of my presentation, and those is an overview about all the hypotheses I had. And you see that everything that's technically related, I marked as solved here. I know that most of you are technical people, so that might raise the issue, or if you are really working on those projects, you won't have the feeling that it's solved, because I mean it's tedious, it's a lot of work. You need to understand data, you need to transform it, and so it's effort, I know, but from the technical side we can really work around that effort, and we can really create solutions. There are other factors into play here why that hasn't been adopted. AI hasn't been adopted in healthcare as we would like it to be. If you want to talk about it more, discuss it, just feel free to connect with me at LinkedIn, or let's talk now. Thank you. Yes.
So my question is, when we have 10 minutes per patient budget, might it be that these 10 minutes actually have such a low value that we should work on replacing this 10-minute consultation with AI instead of improving the workflow of delivering this 10-minute consultation and enabling the professional to focus on difficult cases?
Yeah, I mean, I think that the question is whether the patients would really like that. Also depends from the patient probably. I mean, many people still like to talk to a person. In the study I showed, it's interesting that, because I think that answers this a little bit. Where is it? In that study, 25% of patients said they would rather go to AI than to a therapist, but that also means 75% of people would still like to see a doctor, even if they have only catch the cold.
But is it accessible? And if it's not, do they still prefer that?
Yeah, maybe that's something we can try out over the next years. Yeah, and it probably will go that direction anyway. So to have some barriers, or you can call it barriers, or things that, like a chatbot, that you need to use before you actually get an appointment. And a lot of cases then should be directed to the technology anyway. Like if you try to reach a call center today, where everything is automated until they understand that your problem is not solved.